Hello students, we are discussing about the solution of non-homogeneous linear equations with constant coefficients, right? So in the last class we are discussing about the undetermined coefficient method. Okay, if the theory is you want to see again, just click on the I tag and you can get the video. Okay, so after watching the previous lecture, if the theory is clear, now we can solve this type of problems. Okay, so here I have collected 4 different types of examples, okay, where we can see so different types of undetermined coefficient functions are there. Here we want to calculate the particular integral, right? So one by one we are going to solve it. Okay, so first problem is d square plus 4 into y equal to x square. Okay, so here the undetermined coefficient function is x square. Okay, so whatever the step wise I was discussing in the previous lecture, according to that we are going to solve. Okay, so first of all, what we want to find out, we will find out the complementary function for this problem. Okay, so complementary function will be, that is d square plus 4 is equal to 0. Okay, so d will be our plus minus 2y, correct? So here complementary function will be c1 cos 2x plus c2 sin 2x. Okay, so if you want to know how I got this equation, you can see my previous lecture where I have discussed how we can find the complementary function. Okay, so this is our complementary function for this equation. Okay, now we want to find out the particular integral, right, for this problem. Okay, by the help of this undetermined coefficient method. Okay, so here the undetermined function is x square. Okay, so first step, what is our first step? Step 1. In the step 1 we will find out the undetermined set of functions, right, for this function. Okay, UC set, right? So for this function our UC set will be which one? Let us take S1. Okay, that will be this one, the function itself. Okay, and the derivatives, right? Then 2x is there, so x, then 1. So this is the UC set or undetermined coefficient set for this function x square. Okay, so here you can see that only one complement UC set is there. Okay, so there is no element in the complementary function, so there is no need of omission or multiplication or anything. Okay, so directly we can consider this set. Okay, so to find out the particular integral, we have to take the linear combination of this function, right, of this set. That will be yp, we will assume that one will be our yp, that is a0 x square plus a1 x plus a2, correct? So this one will be the particular integral, and here this a0, a1, okay, and a2 are undetermined coefficients, right? Correct. So this one we have to find out this value. Okay, so what to do for this? This one we have to apply here, right? So d square means 2 times of derivative of this yp, right? So first of all we have to find the yp dash, that is a0 2 into x, correct? Here a1, okay, then this derivative is 0, correct? Again we have to find out yp double dash, that will be a02, right? So now we will put this yp dash, yp double dash, okay, here in the given equation. Okay, then we'll compare the both the sides to find this unknown coefficients. Okay, so if we'll put this one in the main equation, what we will get? That is 2a0, okay, plus 4y, that means plus 4 into a naught x square plus 4a1 x, right, plus 4a2, which is equal to x square, correct? So if we'll compare both the sides, what we will get? That is 2a0 plus 4a2, correct, is equal to 0, correct? Now if we'll compare the coefficients of x, that is 4a1 is equal to 0, that means a1 is equal to 0, correct? Now coefficients of x square is 4a0, right, is equal to 1, correct? So a0 is equal to 1 by 4, correct? So if we will put this a0 value here, what we will get? A2 will be equal to minus of 2 into 1 by 4, that is 1 by 2, okay, into 1 by 4, correct? So this is minus 1 by 8, okay? So now we will put this a0, a1, a2 value in the equation yp, okay, to get the particular integral, okay? So it is a0, that is 1 by 4 into x square, correct, minus a1, this is 0 into x is 0, so a2 is minus 1 by 8, correct? So that will be equal to 2x square minus 1 by 8, okay? So this is our particular integral and this is our complementary function, okay? So general solution which will be equal to yp plus yc, okay? Hope you understood this one, right? Now we will proceed for the question number 2, okay? Our second question is y2 plus 2y1 plus y equal to x minus e to the power x, okay? So first of all we will find out the complementary function, okay? That means this one, that is d2 plus 2d plus 1 equal to 0, correct? So d plus 1 whole square equal to 0, right? So our d will be minus 1 and minus 1. So 2 times the real root. So yc we can write c1 plus c2x into e to the power minus x, okay? So since yc already we got, okay, now we will find out the particular integral using the undetermined coefficient method, okay? So here the UC functions are x and e to the power x, okay? 2 UC functions are there, right? So for each UC function we will find out the UC set, right? So if S1 will be the UC set for x, then what we can write? X and 1, okay? So for e to the power x, the UC set will be only e to the power x, correct? Now the particular integral, what we can write? There is no step 1 and step 2 because here there is no similarity between S1 and S2, there is no subset S1 and S2, correct? And there is no terms present in the complementary function which is equal to S1 or S2, okay? So there is no need of step 1 and step 2. Directly we can proceed for the step 3 where we can take the linear combination of these sets, okay? So that means we can write a0, correct, plus a1x plus a2 e to the power x, okay? Now here a0, a1, a2, a0, a1 and a2 are undetermined coefficients, okay? Undetermined coefficients, okay? Undetermined coefficients. Okay, now we have to find out this a0, a1, a2 value. Okay, how we will find out? This yp we will put it in the left hand side and we will compare with the right hand side to get these values. Okay, so let us proceed. The first one is yp dash. Okay, so what will be our yp dash? That is 0, correct? So this one will be a1 plus a2 e to the power x. Okay, now yp double dash will be, this one is constant derivative is 0 and this one will be a2 e to the power x. Okay, now our job is to put these equations in the given problem. So yt, that means yp double dash, right? So what we can write? a2 e to the power x plus 2a1, correct? That means plus 2 into this one, right? a1 plus 2a2 e to the power x, correct? Plus y, that means this one, correct? a0 plus a1 x plus a2 into e to the power x, that is equal to x minus e to the power x. Okay, now we will compare both the sides. Okay, so if you will first of all, if you will take the coefficients of e to the power x, then what you will get? This is a2, correct, plus 2a2, correct, plus a2. Okay, that is equal to minus 1. Okay, now if you take the constant terms, that is 2a1. Okay, 2a1, this is a0. Okay, which is equal to 0, right? Now taking the coefficients of x, you will get a1. Okay, so a1 will be equal to 1. So putting this a1 in this equation, what we will get? a0 will be equal to minus 2, correct? And a2 will be equal to, this is 2 plus 1, 3, 4a2 equal to minus 1. So a2 will be minus 1 by 4. Okay, so now next job is to put these values in the yp, correct? So yp will be equal to a0, that means minus 2, right? Plus a1x, that means plus x, okay, plus a2 e to the power x, that means minus 1 by 4 into e to the power x. Okay, so this is our final particular integral and this is our complementary function. Okay, so general solution, what we can write? The summation of yc and yp. Okay, so this is our general solution. Okay, hope there is no doubt. Okay, we can proceed for the next problem. Okay, question number 3 is y4 plus y double dash is equal to 3x square plus 4 sin x minus 2 cos x. Okay, so first of all we have to find the complementary function. Okay, that is d4 plus d2 equal to 0. Okay, so d square if you are taking common, then that is d square plus 1 equal to 0, correct? So d will be equal to 0, 0 and plus minus I, correct? So yc will be c1 plus c2x, right, into e to the power 0x, that is 1, plus c3 cos x plus c4 sin x. Okay, now if complementary function is okay, now we can proceed for the particular integral. Okay, this question is very much important because we are going to find the similar functions, UC functions that is present in the complementary function. Let us proceed. Okay, that is so here first of all we will see what are the undetermined coefficients. Okay, so what are the coefficients? That is first one is x square, okay, then sin x, then cos x. Okay, so according to these UC functions, so what will be our set, UC set? That is for x2, if you are taking s1, then that will be x2, then x, right, and 1. Okay. Now for h2, that is for sin x, that will be sin x into cos x. Okay. If you have any doubt in this UC set, then you can revisit the previous lecture so that you can understand these things easily. Okay. So h3 will be the function itself, that is cos x, and the derivative is sin x. Okay. So here you can see that the first step already over, and the second step is, you can see h2 and h3 both are same because the sin x is here and cos x is also there. So we can retain this h3. Okay. So we can omit this h3, we can omit. Okay. Then only we will consider h1 and h2. Okay. So after that, you can see the members which are present in the complementary function, that is also present in the UC set because x is there. Okay. Now cos x is there, sin x is there. Okay. So what to do to overcome this problem? What we can do? We have to multiply with the powers of x, right? Integral multiple of x. Okay. So if you are multiplying with x, okay, here, then what will happen? X cube, that will be x square, and this will be 1 into x is x. So again it is appearing in the complementary function. Okay. So we cannot multiply x. So next is x square, we will see. Okay. So if you are multiplying x square, then here you will get x fourth, correct? Then here you will get x cube, then here you will get x square. Okay. So there is no problem, right? So there is no function present in the complementary function. Okay. So we have to multiply x square. Okay. Let us multiply. So our yp will be equal to a1. Okay. x2 into x2 is x fourth, correct? Plus a2 into x square into x is x cube, correct? Plus a3 x square. Okay. Now you can see 4q x square. There is no term in the complementary function. Okay. But here you can see cos x is there, sin x is there. Okay. Simply if you multiply with x, then it will be x sin x and it will be x square, x cos x, which will be different from these two functions. Okay. So what we will get? A fourth x sin x, correct, plus a5 x cos x. Okay. Now it is clear. So our final yp is this one. Okay. And next job is to find this a1, a2, a3, a4 and a5, which are the unknown coefficients. That one we will find out by substituting in this equation. Okay. So here up to y4 he has asked. So we have to find one by one. So first of all, yp dash will be 4 x cube a1 plus 3 right. Okay, let us do it from once again. That is 4a1 x cube. Okay, 4a1 x cube plus 3a2 x square, right, plus 2a3x plus a4, right, a4th, then that will be our x cos x plus sin x into 1. Okay. Over, then next is a5, that will be x into cos x is minus sin x, correct, plus cos x. Okay. So this is our first derivative. Okay. Next we will proceed for the second derivative. Okay. Let us see. That is 4 into 3 is 12 a1 x square plus 6 a2 x plus 2a3. Okay. Now this one will be a4 into x cos x, right? So that will be equal to a4 into x cos derivative is minus sin x, okay, plus cos x. Okay. into 1, then next is cos x, okay, plus a5, okay, then this one will be x into minus cos x, okay, plus minus sin x is there, okay, into x derivative is 1 plus then again cos x derivative is minus sin x. Okay, now we will proceed for the y triple dash. So y triple dash will be equal to, that is 12 into 2, that is 24 a1 ax, okay, then plus 6 a2, correct, then that will be 0, okay, then minus a4 x sin x. So what it will be, minus a4 is there, then x cos x plus sin x, right, and x derivative is 1, okay. So again here this is 2 cos x, right, so that is 2a4, right, so you can write minus 2a4 cos x derivative is minus sin x, so this one I have taken minus, this is sin x, okay, and this one is over, then come to this one, that is minus a5, okay, so x cos x derivative is minus sin x, okay, plus that will be cos x, okay. Now this one is equal to minus 2 sin x, okay, so that will be minus 2 but it will be minus 2 sin x derivative is cos x, okay. So last derivative is y fourth, okay, so that will be equal to 24 a1, correct, so this one is 0, then this one it will be minus a4 x into cos x is minus sin x, okay, plus cos x, okay. Now this is that one, it will be minus a4 cos x, okay, so that will be equal to minus 2a4, this is cos x, okay, so this minus it will be plus a5 and that will be x cos x plus sin x, right, then this is cos x will be minus sin x, right, cos x derivative is minus sin x, another minus is there, so that will be equal to plus a5 sin x, right. So again this is minus, correct, no, that should be, that should be minus and this minus, that should be minus, okay, if I are taking common then that should be equal to plus, so final will be minus, then cos x is minus sin x, so that will be plus sin x, okay. I think it is correct. Let us check it once again. Okay, now we will substitute this y4 and y2 double dash in this equation, okay. 2 is missing, so that should be 2, correct. So now we will put this y4 y2 in this equation, right, so what we can write then, that is 24 a1, correct, so this is minus, so plus a4 x sin x, correct, this is minus a4 cos x, this is minus a4 cos x, that is also minus a4 cos x, so we can write minus 4 a4 cos x, okay, this is minus, this one is over, right. Now we can proceed a5 x cos x, right, so we can write plus a5 x cos x okay, then sin x is 2, 3, 4, okay, so plus 4 a5 sin x, okay. Now plus y double dash, okay, so what we can write, plus, that should be y double dash means this one, plus 12 a1 x square plus 6 a2x, okay, plus 6 a2x plus 2a3 plus 2a3 minus x4 x sin x. Is there any term? No. So we can write minus a4th x sin x, okay. So this is 2 cos x, right? So 2a4, this is cos x, right? So this one will be minus a5 x cos x, okay. This is minus, that is minus 2 sin x, so that will be minus 2 a5 sin x, okay, which is equal to our 3x square plus 4 sin x minus 2 cos x, okay. Next job is to compare the left hand side and right hand side to get the unknown coefficients, okay. So now we can erase this one. So if we will compare both the sides, so we can get that is 24a1, okay, plus 2a3, okay, which is equal to 0 because there is no constant, okay. So here a4 x sin x is there, right? So again minus a4 x sin x is there, so these two can be cancelled out, okay. So now 4a4 cos x, okay. So any cos x is there? Yes, this one, right? So minus a4 plus 2a4. So what we can write? Minus 2a4, which is equal to cos x, coefficient of cos x, that is minus 2, okay. Now a5x cos x is there, so again minus a5x cos x is there, so these two can be cancelled out, okay, these two terms. Now 4a5 sin x, okay, 4a5 sin x is there, yes, here is another sin x term. So 4a5 minus 2a5 is 2a5, right? 2a5 will be coefficient of sin x is, this side is 4, okay. Now we will go for the coefficient of x square, that is 12a1, okay. So 12a1 is, coefficient of x square is 3, okay. Now we will proceed for the coefficient of x, that is 6a2, okay. 6a2 is there, so there is no other term. So right hand side, that will be equal to 0, okay. So here we can write a2 is 0, okay, a1 is that is 3 by 12, right? So that is 1 by 4, and a2 is 0, a1 is this one, then a4 will be minus 2, that will be 1, correct? 1. So now we can find the value of a3. So 24 into a1, that is 1 by 4. So 4 it will cancel out, that it will be 6, right? So what we can write, a3 will be that will be minus 6, right? Minus 6 divided by 2, so that will be minus 3, okay. So a1, a2, a3, a4, all the values we obtained, okay. So now we can put this one in the our original yp. So our original yp was, that is a1 x4, right, plus a2 x cube plus a3 x square plus a4 x sin x plus a5 x cos x, correct? So now we can put all these values to get the particular integral, okay. So a5 x4, that means 1 by 4 x4, okay, plus a2 x cube, that means a2 is 0, so this term will be 0. a3 x square, so we can write minus 3 x square plus x4 x sin x, right? That means plus x sin x plus a5 x cos x. So where is a5? Here, right? So a5 will be equal to 2, right? So you can write 2x cos x, okay? So this is our final yp, okay? So our general solution we can write as yc plus yp, okay? Though it is lengthy, but it is not difficult if you are finding the if you are assuming the correct yp, okay? Then after that just substitution, if you know the derivative, then we can solve this one and we can easily find the particular integral, okay? Hope this one now over, number 3, okay? Now we can proceed for the question number 4, okay? Okay, so number 4 is y double dash plus 2y dash, okay, plus 5y equal to 6 sin 2x plus 7 cos 2x, okay? So first of all we have to find the complementary function, correct? So that will be equal to d square plus 2d plus 5 is equal to 0, okay? So what the root will get, that is, this is a quadratic equation, so we can write minus 2, right, minus b plus minus b square minus 4ac, that means so that will be 4 minus 4 into 5, that is 20, okay, over 2, okay? So that will be minus 1 plus or minus, that will be 16, so 4i, so that will be 2i, okay? So if this type of root is coming, complex conjugate root, complex root if it is coming, then what will be our complementary function? That will be c1, right, cos 2x plus c2 sin 2x, right, into e to the power minus x, okay? So complementary function is over. Now we will see the particular integral, okay? For that we have to choose the complementary, the UC functions, right? So here UC functions are sin 2x and cos 2x, okay? So corresponding UC set will be, that will be sin 2x and cos 2x, right? So for cos 2x the corresponding UC set will be equal to cos 2x and sin 2x, right? So these two UC sets are same, okay? So we can exclude one of them, okay? Now sin 2x, cos 2x if you are considering, and you can see there is no member present in the homogeneous solution of this equation, that is cos 2x sin 2x into e to the minus x is multiplied, okay? So there is no similarity, okay? So we cannot delete anything. So next step will be our yp, okay? So what we can write, simply a1 sin 2x plus a2 cos 2x we can assume, right? So next job is to find the value of this unknown coefficients a1 and a2. This value will put it here, okay? So what we can write then, yp double dash we need, right? So first of all yp dash will be equal to that will be 2 into a1, right, sin derivative is cos 2x into 2 is coming to that side, okay? So now cos 2x is minus sin 2x, okay? Again 2 is will multiply, so what we can write, 2a2 sin 2x, okay? There is no problem. Now yp double dash, what it will be, it will be 2, again it will multiply, cos derivative is minus sin, so we can write minus 4a1 sin 2x, okay? So now again sin 2x derivative is cos 2x, right, and 2x derivative is 2, so we can multiply here, that is minus 4a2 cos 2x. Okay, so first derivative, second derivative we got. Now next of which we will put it here, right? So what we can do, we will get to then y4 y2, right? So we can write minus 4a1 sin 2x minus 4a2 cos 2x, okay, plus 2y1, that means 2. Okay, so what we can write, plus 2 is there, right? So this should be equal to 4a1 cos 2x, correct? Again minus 4a2 sin 2x, right? Minus 4a2 sin 2x, okay, plus 5y is there, okay, so plus 5y means 5a1, okay, sin 2x plus 5a2 cos 2x, which is equal to 6 sin 2x plus 7 cos 2x. Okay, so both the sides will now we will compare to find the values of these coefficients. Okay, so next step what we can solve here, minus 4a1 sin 2x, right? Here is sin 2x, here is sin 2x. So minus 4a1 plus 5a1, that will be equal to a1 sin 2x, correct? So that is a2, that is different. So we can write a1 sin 2x, okay. So again minus 4a2 is there, right? So better we'll write once again, that is minus 4a2, only these three terms are there, right? So what we can write, minus 4a2 plus a1 sin 2x, okay. Now here 4a2 cos 2x, okay, here 5a2 cos 2x, so that will be only a2 cos 2x, okay. So here plus 4a1 is there, 4a1 plus a2 is there, and cos 2x. So how many terms are there? 1 2 3 4 5 6, 1 2 3 4, and 2 terms are entered, okay, it is correct. So it is equal to 6 sin 2x plus 7 cos 2x, okay. So what we will get then by comparing both the sides, that is 4a2 plus a1, which is equal to, what we can write, sin 2x, this is sin 2x, so coefficients will be same, okay. Now again 4a1 plus a2 will be equal to 7, correct. So from this equation we can write a1 is equal to 6 plus 4a2, correct. So we can replace here in the place of a1, that is 4 into 6 is 24 plus 16 a2 plus a2 will be equal to 7, okay. So this is 17 a2 equal to 7 minus 24, right? So a2 will be equal to minus 1, okay. So putting this value of a2 here, what we will get, a2 is minus 1, so minus 1 into minus 4 is plus 4, okay. So a1 will be equal to 6 minus 4, that will be equal to 2, okay. So a1 is 2 and a2 is minus 1. So now our job is to put this value in the complementary function, okay. Okay, so what we can get then, ip is equal to a1 sin 2x, that means 2 sin 2x, correct, plus a2 cos x, that means minus cos x. Okay, so that is this is our yc and this is our yp. Oh sorry, this is yp and this is our yc. So general solution will be equal to the sum of these two, correct? So now taking the sum, that is general solution will be yc, that means c1 cos 2x plus c2 sin 2x into e to the power minus x, correct, plus 2 sin 2x minus cos x. Okay, so this is our general solution y. Okay, so here the condition has given at y of 0, that is 1. So putting x as 0, okay, y of 0 means y of x. Okay, so 0 if you put it here, then that will be c1 into 1, and this one it will be 0, and e to the 0 is 1. Okay, so again sin of 0 is 0 minus cos x, that means minus 1, which is equal to given 1. So what we can write, the value of c1, that is 1 plus 1, that is 2. Okay, c1 value is 2. Okay, now to apply this condition we have to take the first derivative. Okay, so if y is this 1, then what will be the first derivative? That will be c1 is constant, so cos 2x into e to the power minus x, right? So what we can do then, that will be cos 2x, okay, into e to the power minus x, derivative is e to the power minus x into minus 1, correct, plus e to the power minus x into cos 2x, derivative is minus sin 2x, okay, into 2. Okay, so this is over. Now come to this one, that is c2. Okay, c2 is there, so what we can write, sin 2x into e to the minus x, derivative is e to the minus x into minus 1 plus e to the power minus x into sin 2x, derivative is cos 2x into 2. Okay, this is over. Now come to here, that is plus 2 sin 2x, sin 2x derivative is cos 2x into 2, so we can write 4 cos 2x. Okay, then cos x derivative is sin x, so we can write minus sin x, so minus minus, this is plus. Okay, so this is the first derivative. So what we can write then, y dash of 0 is 0, that means wherever x is there we will put as 0. Okay, so what we will get, c1 into this is 0 means 1, again e to the power 0 is 1. Okay, so minus 1 is there, so c1 into minus 1 is minus c1. Okay, and this term is 0, okay, because sin term is there. So again this one is 0 because sin of 0 is 0, and here cos of 0 is 1. Okay, so 2 is there, 2 into e to the power minus x into c2, so e to the power, again this is 0 is 1, so what we can write only, that will be 2c2, correct, c1 plus 2c2, right, plus here 4. Okay, cos of 0 is 1, then sin of 0 is 0 is equal to 0, it has given. Okay, so what we can solve then, we know c1 value is 2, so we can put it here, minus 2 plus 4 plus 2c2 equal to 0. So what we can write now, c2 will be equal to 4 minus 2 is 2, correct, so that side if it will go, then that will be minus 2 divided by 2, so that will be equal to minus 1. Okay, so c1 is equal to 2 and c2 is equal to minus 1. From this given initial condition we got. So what we can write, our final y. So our final y will be equal to c1 cos 2x, that is 2 cos 2x, c2 sin 2x, that means minus sin 2x into e to the power minus x plus 2 sin 2x minus cos x. Okay, so this is our final solution. Okay, so I hope it is clear to you. I have taken 4 different type of UC functions and I explained in detail. Okay, if you understood this type of equations, then you can try more and more problems, okay, which you should try to solve this by UC method. Okay, so I will try to come with the next video. Okay, the method is variation of parameters. Okay, so thank you so much.